Friends, welcome to One Little Coder. In this PyScript tutorial, we're going to learn how to include machine learning in your PyScript web application. So if you're not familiar, I've been doing a PyScript series so far. And in this series, we have reached the machine learning part today. And this video, where you're going to upload a CSV, do a prediction, and then also have an interactive drop down like this where you can change the prediction. So that is what we're going to build. We're going to use Scikit-Learn linear regression, a very simple machine learning model, because the bigger the model becomes, the longer the web application would take. So I wanted to keep it simple. So we're going to build a linear regression model that just completely runs on the website browser, like web page browser, and everything is on client side, no server required. And we are just going to learn how to do this. If this is something that interests you, let's get started without further ado. So the application looks just like this, where you are going to upload a CSV file. Let me quickly show you the demo. So I'm going to say temp.csv, and I'm going to upload and drag and drop down the CSV. And then I'm going to click show prediction. The moment I click show prediction, you can see. So what we are trying to predict is, based on the number of installs, we are trying to predict RP. RP is an average revenue per installation. So if I increase this, for example, right now it is 500 installations. So if I say our installations are going to be like, let's say 100,000, and then you would see click show prediction, you can see the RP increasing. So based on the way that your installation is going to increase, you're trying to predict how much is your RP is going to change. This is a very important problem to solve if you ever have worked with app data, if you have ever worked with gaming data or anything where you have installations. And if you're going to do CLTV stands for customer lifetime value. So if you're going to do CLTV modeling, this is something that you might end up doing. And I'm going to show you how to do this using your PyScript. So let me get into the code. So if you see the code is quite simple. Our PyScript part is the same. So we are importing the required JavaScript libraries for PyScript. So we have got Vega, again Vega, tabular, a table, bouquet, and then panel. So basically, the panel is what we are going to use for a couple of components that you saw in the interface. For example, this button, this, and this, all these three are from panel library. So we are going to just simply use these components. These are the JavaScript components that are required for us to design those UI components. So this is done. So the next thing is, as usual, you know that because we are going to deal with PyScript, we have to import PyScript CSS and we have to import PyScript.js. So we are just referring those things as part of our web application. So now that is done. So the next part is the PyScript part, which is where you declare what are the PyScript environment libraries that you want. So the libraries that you want should be defined here. One thing that you should keep in mind is you cannot use any library at this moment. So the PyScript that we are using is actually powered by something called Pyodide. So Pyodide has a list of libraries, Python libraries that Pyodide supports. So you have to always refer back to it to make sure that the library that you're trying to use is supported by Pyodide. If not, you cannot use it. Somebody has to actually port it to Pyodide, for it to be used with WebAssembly, just like the Streamlit Lite tutorial, ST-Lite tutorial that we saw a couple of days back. For now, these are the libraries, and all these libraries are supported by Pyodide. So what are we going to say? We are going to pyenv open, pyenv close, and these are the library. NumPy for numerical computation, Pandas for tabular manipulation, Matplotlib for chart. Even though right now I'm not doing any chart, I just imported it because I was iterating a lot of code and I was using charts. Seaborn again for charts, Scikit-Learn for machine learning, and Panel for the UI components. So these are the libraries that we want to use in this Python web application. So this is done. Now at this point, our head is finished. So our head is finished, which is more like your meta information, like things that you want to include in your web application and all those. Now we are entering into a territory which is the body. The body is where you're going to define what you want to show and what happens in the backend. So the front end and backend ideally goes inside body. Another thing about the backend, you can have a PyScript separately as a .py file, and then you can refer it just like how you did a JavaScript. But I'm to keep it simple, I'm writing my Python code as well in the same HTML, which is not ideal if you're going to actually develop something in production. But again, PyScript is so early, we are not going to develop things in production. So this is more of educational purpose. So inside your body, if you see, I've got an h1 tag that says upload CSV. To quickly show you the upload CSV tag, we have the output of the upload CSV, we have upload CSV. The next thing is you need to define a file input. So we are going to just have placeholders like div component where we are going to fill in some UI component. So right now it's going to just show the div component. What is first? First is file input. This is your file input component. What is next? Your upload. You have a button where you're going to say upload, or in this case show prediction. I mean, I called it upload, but you can call it whatever you want. The next is the place where you want to define for what value you want to do the prediction. So if you know about machine learning typically includes two major components. One is machine learning model training, ML training. The second one is ML inference. So ML training is the first part where you actually train a machine learning model using existing data. ML inference or prediction is a part where you use the model that you just built and then you try to predict for something. So typically, you would have ML training, ML inference. In this application, we are going to actually do both, which means we are not going to deal with pickle files. We are not going to save or upload pickle files. We are doing machine learning training as well. We are going to do machine learning inference as well. And for that, we have the prediction, the output of the prediction is going to be. So here, once you upload the CSV and click this button first, the model is going to be built. After that, based on what you have here, the model is going to do inference of prediction. Okay. So that's what you see here, the result. Imagine this is in dollars. So ideally, you're looking at 50 cents as your CLTV, customer lifetime value, for 100,000 installations, something like that. It depends. Right now, I'm using some dummy data, but you can actually change it and then use the proper data and then try it out to see how it works out. And again, the model that I'm building is quite naive, very basic. It's no hyperparameter tuning, no cross validation, no model validation. This is not ideally how you're supposed to do machine learning, but again, to keep the scope of this video quite minimal to show what I wanted to show, which is how to do machine learning using PyScript, I've kept it minimal. Just don't do machine learning just like how I'm showing you. Okay, so that is our UI component. So we have got file input, upload to predict, this one, and then we have got the final output, regression output. This one I had kept it actually for visualization. If you want to show, if you're not showing, that's fine, and nobody's going to question you. Okay, so now is our front end designing is finished. At this point, our front end is done. Now we are going to enter directly into our PyScript part, where we are going to define the Python code within our HTML file that will do reading the CSV, building the machine learning model, doing prediction for the value that we have given there. Okay, let's get started. I hope until now it is clear. So if you have any question, always go back. But until now, we have defined the front end. Now we are going to define the backend side using PyScript, which is ideally Python. First thing is we need to import the required libraries. So we have already defined what all libraries that we wanted here. Now we are going to import that library into our Python environment session. So matplotlib, Cbond for visualization, pandas for data manipulation. One thing that I've already said in the past is Python is everything that happens in Python is line by line. So it's a language which executes things sequentially, but a lot of things that happens on a browser is asynchronous. It's not going to happen one by one. Sometimes something happens, then something else happens. So it's an asynchronous process. So for you to get that asynchronous execution in Python, you need async IO. Next is panel for UI components. So again, we are going to show some components using panel. So that is why we are using import show. Next, we have NumPy. I mean, ideally, I should have imported NumPy. NumPy, I'm using certain array manipulation for linear regression. And then finally, from Scikit-Learn linear model, we are importing linear regression. This could be XGBoost. This could be any model that you want. But again, like I said, to keep it minimalistic and simple, I'm just going ahead with linear regression. But please try it out with different models, so you would get different results and different experience about how much time it takes and all those kind of stuff. So now we have imported all the models successfully. The next thing that we need to do is we need to define the input components. We have already given the placeholders where we are going to fit in these input components. Now we are going to actually define the input components, UI components. Again, just remember, in my case, I'm using panel. You could do the same thing with vanilla HTML. Like you could do the same thing with HTML without using panel. But using panel, couple of things are easier. For example, reading CSV is really, really easier. I've got two tutorials on reading CSV. If you remember one tutorial where we had not used panel, we had to do a lot of hopping around here and there to actually read a CSV. The other tutorial we used panel and it was quite elegant and easy, very Pythonic. So I'm using panel for that. But if you want to avoid dependencies, don't want to use panel, you could still do the same web application using all my previous tutorials. You'll be able to do machine learning with that without using panel at all. But right now, I'm using panel. Panel widgets, first file input, and this is the file input where we are saying we want to explicitly accept only CSV. So this is like file input validation, usually a good thing. If you like, imagine somebody uploads a PDF here, somebody uploads a .txt file here, you don't want that to happen. So just a validation, it's a good point. So pn widgets file input, so you're saving that in a file input object. And then you have got the next one is show prediction. So you've got show prediction and you're saving it in, it's a button, saving it in upload button. And then finally this is called a spinner, and then where we are saying we want total installs, and the default value is 500. It's going to start from 50, but it is going to step 50. So if you see, it's going to step 50. You can see it's stepping by 50, and that's what we have defined here. And at this point, we have got the 3 UI components. Next thing is we need to define a function which we will call back later. That function is going to do things when this button is clicked. This button is clicked, the function is going to do certain things. What is it going to do? First thing is it's going to read. Okay, first thing is you want to make sure that there is a file uploaded here. So you're saying if file input value is not none, which means something has been uploaded. Not none means something is there. If file input dot value of this is not none, then first thing, read the CSV file. While you are reading the CSV file, you have to make sure that you're doing io.bytes.io to get the value. Like you take the value of that, whatever value that you have here uploaded, and then you read it as a CSV. Now at this point, you've got data. Data is a data frame here. So now in my case, I've got RP and I've got total installs, but make sure that you change the name, whatever name that you want, based on your input file. Again, if you want to do it dynamically as well, you can use iloc to do it. But in my case, I'm just simply taking the name, hard-coded RP and total installs. So the way I see this application is, imagine like I'm a data science team for a big retail agent. I want to install a forecasting application for all my retail managers. So I know what is the input data set. I know what is the output data set. I know the column names. I would hard code it like this. So this is the kind of application I have got in mind for such a PyScript application. So yeah, so we have the first column name RP that is stored in Y. I mean fittingly because we are trying to predict Y. And then we have got the total installs. We are saving it in X. In this case, uppercase X. You can use any name, it doesn't matter. But in machine learning, if you are used to machine learning, it's always Y is equal to MX plus C. So traditionally from statistics, you know Y is what you want to predict, X is what you are using to predict. So explanatory variable and the response variable. So you know that component. So that's why you are using Y and X here. One is what you're going to predict. Like this is what you're going to predict, and this is what you're using to predict Y. Okay. So now at this point, we have read the data set. So click the button. If file input is not empty, then read the data set, assign the particular column values into Y and X. So the next is the regression part. So now that we have our Y and X defined, I mean, if you're using a different column name, you can change it here just to keep it simple. But what are we going to do next? We're going to use linear regression and say we want to first. So usually what people do is they will do linear regression and then model.fit, but we are doing it in one line. It's up to you. You can do it the way you want. Right now it's quite simple. So you do linear regression. Ideally this would be a line, and then dot fit. So you're fitting the model with X and Y. And then if you want to see the score, print the score, you can do that. If you don't want it, you can leave it out. I'm printing the coefficient. When I use print in Python, it's equivalent to console.log in JavaScript. So it's not going to print on the web application. Rather, it would print it on the console.js, like the console. So if I have to show you, if I inspect, go to console, and then if I, console, and if I click show prediction, you would ideally see this somewhere here, right? So you see this value here. So this is different from this value because this is what you're printing as coefficient. So print actually prints there. This is just for your debugging purpose if you want to see what is happening. But again, the ideal approach is I would suggest you do not even you shouldn't be writing machine learning code from scratch here. So what I did in my case, like I had a matplotlib, so I had a Jupyter notebook within my VS Code. I developed my machine learning code here, and then I imported it and I got it here. So that's what I did. Really, that's what you should be doing. It doesn't matter whether you're going to use Jupyter Notebook or whether you're going to use something else, but I would still say do not write your Python code from scratch inside your VS Code, inside your PyScript application. That doesn't work. Indentation, a lot of factors are there. So probably better write it somewhere and then copy paste it here, just like I did. So now we have built the model. We have printed certain, coefficients that we wanted to see. Now is the point where we are going to predict the value. So model, in this case, it's called reg dot predict. So what is the predicted what do you want to predict? I want to predict based on this one. Whatever is inside this, let me close this at this point. Whatever is inside this, I want to predict based on this. So first I have to read this. So now we already know that this has been called as 2 underscore predict, and we have object 2 underscore predict. So this 2 underscore predict is written here, like this object is written here, and this 2 underscore predict dot value is here. Okay, so now because this is a scalar value, which means it's a one like single value, I'm doing a reshape here. So I've got a scalar value like single value, single sample you can call it. So I'm reshaping it in a way that the predict function would take. So the numpy is again used here and predict. So now the predicted value, ideally this array is stored here. Now we need to find a way to write this output to the front-end application, the application that we have got. So until now we have successfully managed to predict. Next thing is quite simple. We already know that we have created a component here called regression op. It stands for output. So I'm getting the element. Now I'm using element. If you see, I'm not I'm using the PyScript component element, and I'm reading it, the component value, which is I'm reading it as reg underscore op, and the predicted value I'm writing it to it. So at this point, what I'm trying to do is we have already predicted, we have got an array there, and I'm reading this component, this component, and I'm writing this value, text value, as a paragraph text. So you're basically writing this one. So at this point, the function is completed. Like what we want to do when we click button is completed. So, but if you still remember one from my previous videos, all these components are individually present here. You have the placeholders, right? And you have the front end components. But so far you have not made that link. You have not said that this file input should go inside this file input. You have not made that connection, right? So that is exactly what we're going to do next. We're going to say await show. Show is to write a particular component inside a particular div like container. You're saying write file input, which is here, file input, right? Inside this. Right? Upload button inside upload. Right? To predict a show. To predict inside to predict. And then finally, you're going to define an event listener. In this case, you're saying when this is clicked on click, this is the callback function that you should call. This callback function is called. I think now your application is complete. So at this point, your application is perfectly complete. So just to show you how much time it takes, I'm going to save this at this point. I'm going to go back here and it's going to refresh because I saved it there. So you can see how much time it takes in real time. So basically it takes quite a bit of time, and that is quite understandable at this point, given that PyScript is quite in an early stage. But I hope like going forward the time would come down. It also has a lot of factors, the number of components that you add, number of JavaScript components that you have, how heavy your application is, and like if you're doing any machine learning operation, like what are the things that you're doing. So for now you can see that the first one, the h1 tag, has successfully come. Now h1 tag was in part of HTML, so then it is coming, and you can see it start from 500. So I can now choose file, or I can do temp.csv, and then I can just drag and drop it here, and temp.csv is here, and then I can click show prediction, and you can see 37 cents. Like for example, if our installs increase and I would click show prediction, it's like whenever installs are like 5 million, so our see like RP increases to approximately $7 from 50 cents. I mean, like that means like we are like Facebook or some very big organization. But the point is, our machine learning application, it's really fine. To quickly also show you that the coefficient part. So you can see that I said I'll print the coefficient here. So you can see the coefficient being printed here. For example, every time I click something, you can see the coefficient here, and also the final value that is being written on the front end. So quickly summarize what we did in this video. We created a front end application. We created a PyScript application that just completely runs on the client side of the browser, not no server, where we are taking the CSV as an input. We are building a linear regression model, and then we are going to use user input, get a value from the user. For that value, we are going to use this model and predict what would be the output. In this case, usually the classical example is people would use house prediction, people would use something like that. But I wanted to take slightly more practical example. So what we are trying to do is we're taking total installs of the app and we are trying to predict the RP, average revenue per installation, which is quite important if you're going to do CLTV, which stands for customer lifetime value. And our code looks like this, where we have a PyScript code where machine learning prediction happens. Front end components are defined using panel, and then finally we just finally write out the output, and that's it. If you want to show charts, like I already told you, you have got places where you can write charts. They was there, so all you have to do is matplotlib and write it. You have got enormous opportunity, but I hope this video was helpful to you in writing your first machine learning model, machine learning application using PyScript on the web. Python for the web, it's quite interesting. If you have any comments, let me know in the comment section. Otherwise, this code will be in the YouTube description as a GitHub repo. Please check it out. Please give a thumbs up to the channel, a video if you like. Subscribe to the channel, share it with your friends. Happy coding. See you later. Peace.